Greg is a wells and pipeline operations manager and responsible for the whole pipeline network in the greater Los Angeles area, an area of more than 30,000 square miles, by the way. His main responsibility is to manage incidents and non-productive time and keep the latter to a minimum. In order to do so, he needs to sense aberrant situations and respond to them adequately. In case of imminent or actual incidents or non-productive time, Greg needs to react by triggering the process of repair or replacement of the affected parts. He needs to choose the right and most profitable process. So how does Greg get all this information from a pipeline network in this far-stretched area in the first place? In order to get all this data, the pumps in the pipeline network are equipped with sensors, the IoT. Now let's look at how Greg can sense, act, and track upstream incidents and thereby efficiently run low-risk operations.
So Greg is working with multiple devices. He's looking at an iPad where he's seeing what is the pipe status. It all looks green. Then he's looking at the infrastructure, the stations that are there. No major issues there. He sees 2 low alerts, so he's not really worried about that. But then when he looks at production, there is something red here. So he wants to really figure out what's going on here. So near Whittier, so he goes down and sees what the issue is. Here he sees that there's going to be a potential hydraulic pump failure. And there is 224 hours estimated to this failure. The reason why he has the alert is because there are pressure sensors which are saying the pressure is falling, and there are temperature sensors. And then based on this, there is intelligence gathered that this could be a potential incident and we need predictive maintenance for this. The pipeline integrity is threatened. Based on geodata, it also says there are schools and hospitals nearby, and there are next best actions that are recommended. It says you could either replace a pump or repair the pump, and he also sees what are these options costing me and how long is it going to take to get this done. He can further go down and look at what are the recommended actions. There is going to be a production impact. There are these 2 options. Replace seems cheaper and also can be done faster. He can really analyze with analytics what's the best pump to replace it with. He's got 3 options: Haldex, Permco, or Bosch. In this case, Haldex, though it costs more, from past data he figures out that the total cost of ownership is low. So he can make up his mind and he can look at, okay, who the system is also proposing him, who could do this job. So Terry Halverson is the pipeline maintenance engineer who could do this job, and the system is saying the part could be ordered via a business network, the Ariba business network, from ANFS suppliers. And this is going to be the total cost. So he can review and finalize these recommendations. So he looks at it, this is how much it's going to cost me, and he can complete an audit. So this is what Greg does when he senses certain situations. There are recommended actions which Greg could take and deal with these situations. So what happens is actually a workflow is orchestrating the whole thing, and the next thing Greg would want to do is really track these incidents. Right? From an operations perspective, he wants to look at what are the different upstream incidents, what are the incidents on the well, what are the incidents on the pipeline. So he wants to have end-to-end visibility, right? And the key KPI that he's measured on is incident to recovery. How long does it take for incident to recovery? Now he goes in here and based on a free text search, he's looking at the current incident that he's looking at. And he sees the status of this incident from a high-level process perspective based on phases and milestones. Right? He doesn't look at a BPM diagram for sure, but this is what he sees. There are new incidents that are in here. There is a planned response. The order material has been done, and the responsible person has been assigned, and it's currently for the person to react on. It's 21.5% complete, and there is also forecasted, the system forecasts cycle time and says this is when it's going to be done. If needed, he can drill down and look at more information, and he could also take actions like calling an engineer or raising investigation on top of this. So this is the overall process. So that's from a specific incident perspective, but this is the overall process. He gets end-to-end visibility from how many new incidents were there, what is the planned response, and resolution. Here he sees that there are several issues that are in resolution which are in red. The first thing that strikes him is there is a very high well incident which can lead to a lot of non-productive time, and he's seeing where the process is. The forecasted time it's going to be delayed. And right now the process is stuck in the resolution phase, and the system is prompting him saying this needs manual intervention. It's also giving him a checklist that this is something that you could employ to work with. The checklist has some proposed tasks. He decides, okay, I don't want to review the progress, but what I definitely want to do is escalate to the regional HQ, and he can, in a very easy fashion with tasks, get Manny, who's actually part of the regional operations, regional HQ, escalating issue. So he could escalate this issue. He could also say, okay, the due date has to be by tomorrow, and the priority is very high. So right in the context of the process, he's collaborating in order to solve a particular problem. And when this issue is fixed, and when Manny is working on this, if the investigation is complete, he can say the investigation is complete and the process moves ahead. So we're introducing pockets of flexibility within a big process. Greg could also look at, okay, where are my open incidents? How many are critical? There are 91 critical incidents. So this doesn't really help him, but he wants to figure out where exactly the problem is. So he wants to look at problem clusters. Operational people always want to look at problem clusters so they could focus their efforts on those problem clusters. So in this case, he's looking at a big problem cluster. He's looking at where is the highest severity. He wants to focus on a particular part. So he says filter it down into high, critical, and slow progress incidents. He can say which locations are these incidents. And he could also say, okay, what's the incident type? So this way, based on different dimensions, he could really focus his attention on bigger problem clusters. For example, the Sanner field is where there are a lot of slow progress incidents, well incidents that are going on, and he could say, okay, this is where the problem area is. And again, collaborate with his colleagues via collaborative tasks. So the KPI, which is incident to recovery, is quite critical for Greg because this determines how long does Shell take to react from an incident to the time where they could really recover. So he could look at these KPIs. He could look at the KPIs based on different dimensions. So this is not historical data. So every time an event happens in the process, he gets this visibly out there. He could subscribe to it saying, let me know every hour whenever there is a violation or at risk. So the system would intimate him via email or SMS or any channel he chooses. So Greg's also looking at something that's coming up here. So he sees what we call as a business situation. A business situation is a threat or opportunity that is in operations. And in this case, it's telling him Gary is overloaded. Gary, a service engineer, is overloaded with 5 workloads. And this is based on business rules. The system is detecting these situations, right? Earlier, people used to run reports across multiple systems to get something like this, get an insight like this. In this case, it's also proposing him an action. It says find new service engineers. And he could either do this manually, or he could just let the system, take over in autopilot mode. The system is figuring out that Stanley Cooper has less work, and 2 orders can be assigned to him. So this is how Greg is sensed, acted, and also tracking, incidents that are happening in upstream. So Terry, who has the work order, is actually a service engineer who is who's actually on the field, and he's wearing one of these wearables, right? So he's got Samsung Gear. Okay. On his wearable, he could either clock in time, he could look at work orders. There are 3 work orders that are out there. He can go to one of the work orders. It says replace the hydraulic pump. So he could go into it and he could see details on what this work order is, right? And once he's also got the part, he can replace this part, and he did the task. And he could also say, okay, I want to attach an audio recording. He's wearing a wearable and he cannot really write notes into this wearable. So he says, I want to do audio recording, and automatically the task gets completed. System being built on the smart process services that we have. The smart process services are on the HANA Cloud platform. So a developer goes to a web browser, he goes to the HANA Cloud platform. There are a bunch of services that are out there. There are smart process services that he could take. There are also other services like document services and feedback services, gamification services, IoT services for edge intelligence, all these services. So he could pick and choose the services that he needs. All these are microservices that he could pick and choose, and then on top of which he could build a smart process application. He could either use a web browser to build this, but I'm still traditional. I like Eclipse, so I've got the Eclipse interface. And what we've done here is to take a low coding approach, right? Where we let a solution expert or a developer to collaborate with business users and model his workflows out there. Along with the workflows, he could also model. The workflows could get quite complex. The business users may not understand it. So he could also model high-level phases and milestones on the workflows. He could define goals. He could define attributes, measures, indicators, actions, checklists, business situations, and all of this. He could also define rules that are needed. And once he defines all of this, this is nothing but BPMN2 with extensions, of course. So, you could see the BPMN file. Just that he could just say, pass this on to the compiler. So the compiler is running on the cloud, and it compiles all the necessary artifacts that are needed to run the workflow and the intelligence associated with it. So what does it compile to? So the workflow actually gets compiled to JavaScript. So we really thought about if we have to build a workflow microservice, what is the right technology to use, right? And that's exactly the time where we had the event loop models coming in with Node and JavaScript. So that's the way we went. So we have JavaScript code that's getting generated. We also have a very thin process virtual machine written in JavaScript, which can orchestrate this process. And we also generate a lot of HANA content. So HANA is our in-memory platform, which does all the number crunching and the aggregations that you saw, and also all the correlations. So we generate that kind of content as well. And that's it. So the developer doesn't have to bother about it. He just has to model and then press a button. But there are, of course, exits. If he wants to write code, there are, of course, exits that he could use to write code as well. So process services like decision management, process management, and process intelligence are built as microservices, which are resilient and can scale for large volume scenarios. When you're talking about IoT and sense, act, and track scenarios, it's cloud scale, large volumes. So we should be able to deal with that, scale appropriately. We built from the grounds up in-memory cloud scale workflow engine based on the JavaScript event loop. And we tried to converge a lot of these pieces that are needed, the IoT technology that's needed, the streaming technology that's needed, the process intelligence, process automation, the decision management, try to make this really cohesive and bring it all together with a focus on making a smart process app development platform available to developers. So that's all we had to show.